In this video, we're going to talk about oxidation reduction reactions of alcohols, aldehydes, ketones, and carboxylic acids. So this is a diagram of the different oxidation reduction reactions that alcohols can undergo, and aldehydes, ketones, and carboxylic acids. You can see that a primary alcohol can undergo oxidation to an aldehyde, and in the presence of water, it will go to carboxylic acid. Carboxylic acids can be reduced to aldehydes and then further reduced to a primary alcohol. A primary alcohol is a alcohol that's bonded, that the carbon that's bonded to an alcohol is bonded to one R group. Secondary alcohol, the carbon bonded to the alcohol group is bonded to two carbons. A secondary alcohol is oxidized to a ketone, not an aldehyde, and then it is no longer, a ketone cannot be oxidized any further because there are no carbon-hydrogen bonds attached to this carbon, so it cannot be oxidized any further. Ketones can be reduced to secondary alcohols. Tertiary alcohols, where the carbon that's bonded to the alcohol group is bonded to three R groups, does not undergo oxidation at all because there are no carbon-hydrogen bonds to the carbon that's bonded to the alcohol. It cannot undergo oxidation and therefore cannot undergo reduction either. So for a breathalyzer test, it is the ethanol in your breath undergoes oxidation reactions. The ethanol is oxidized to ethanal, which is the aldehyde. The common name for ethanal is acetaldehyde, which is further oxidized to ethanoic acid or acetic acid. It's the same thing, it's just the common name. The oxidizing agent in the breathalyzer test is chromium-6. Chromium-6 complex is bright orange, and then when it's reduced, remember the oxidizing agent in a reaction is the one that gets reduced. And so when chromium-6 oxidizes ethanol, it gets reduced to chromium-3 and turns dark green. So then the concentration of chromium-3 is determined based on the shade of green in the breathalyzer, which is then the data from that is extrapolated and indicates the amount of alcohol in a person's breath. So there's information within the breathalyzer that analyzes the exact shade of green that's in there, which wavelength that green color is at, and that corresponds to the concentration of ethanol that was originally, that's in the breath of the person who blew into the device. You see on the bottom here that we have a primary alcohol for ethanol, goes to the aldehyde, and then goes to the carboxylic acid. So for practice, we want to predict the structure of the product formed in the following reactions. And if no reaction occurs, we need to indicate why. Have the little diagram to the right to help you. Go ahead and pause the video, and when you're ready, turn it back on and we'll go through it together. Okay, as a reminder, the H corresponds to reduction or being reduced, and the O is oxidized. So we have this ketone. This is a ketone. The ketone is over here being reduced, goes to a secondary alcohol. So this, and remember, during reactions, the thing that gets changed in a reaction is the functional group. So we have 1, 2, 3, 4, 5, 6 carbons. Draw my Lewis structure out. My carbons and hydrogens. My ketone turns to an alcohol, and I get another hydrogen there. So this part is what changed. It went from a ketone to an alcohol. Here we have a primary alcohol. Primary alcohol oxidized goes to an aldehyde. Like this. Now it can be further oxidized to a carboxylic acid in the presence of water. Most of the time, it keeps going to the carboxylic acid. There are some reagents that you can put in to make it stop at the aldehyde stage. But if we just assume that it goes the one step, it goes to an aldehyde. Here we have a tertiary alcohol. We have the carbon bonded to the alcohol group is bonded to 3 R groups. Oxidation of a tertiary alcohol, it does not happen because there are no carbon, so no reaction. RXN is reaction because no carbon hydrogen bonds on this carbon bonded to the OH group. So therefore, no oxidation can occur. So in summary, primary alcohols are oxidized to aldehydes, secondary alcohols are oxidized to ketones, and tertiary alcohols do not undergo oxidation. An aldehyde can be further oxidized to a carboxylic acid, and analogous reverse reactions are reduction.